Ladyada.
Hey everybody, and welcome to my desk. Happy Pride weekend, everybody. We've done a whole bunch of RISC-V hacking this weekend. Just turns out like two RISC-V chips. The CH32V203 and ESP32-C6, both boards designs. I wanted to wrap those up and send those out. So first let's look at the sorry, one second. I got like 15 things on my desk here. The WCH 32V203. So you know the overhead. Zoom in. Okay, get nice and close. Okay, so this is a cutie pie design, and that's the CH32V203 G6 there. It's 32K of 0-weight flash. Apparently there's another 200K of like external QSPI or SPI flash. 10K of RAM, 2 buttons here, one for entering boot mode and one for reset, power, NeoPixel, stemma QT, and what I wanted to do is keep this nice and inexpensive, so it's single-sided, nothing on the back. And this is a 4-layer board because there's a bit of a rush, but over the weekend, actually, I also updated this to be 2-layer. So, you know, it's castellated, so there's a little bit of cost, but like it'll be a, you know, fairly inexpensive cutie pie. So the challenge with this is that to use it, a lot of people are using the CH003 Fun repo by C and Lore, and it's like amazing and totally cool. But a lot of beginners, I think, struggle with using makefiles, even like when they're extremely well documented. So having it be usable in Arduino is like, to me, kind of like a requirement because a lot of folks are familiar with it. And I've got like hundreds and hundreds of libraries. So it's like when people want to like connect a sensor or an OLED, it's a lot easier if it's like, oh yeah, we have, you know, that code ready to go. I don't have to port it over to a different tool chain. So what's really cool is in the last week or two, so go to the computer, the Open WCH repo, which is from WCH, the company that makes this chip. They have a repo for Arduino support, which has been like okay, but not great. One, it doesn't support the C6. Second, it didn't have native USB support. So the chip has native USB. You can have it act like a USB device. You remember we got that working with the CH552, the 8051 core, but this is like a much nicer, fancier RISC-V. You know, if you have USB, you should use it. So getting TinyUSB working with it as well, and then also making it so you don't need an external uploader. So historically, to use this repo, you need a thing called a Linky. Wait, CH Linky? I don't know. It's an external like SWD programmer. And there's nothing wrong with using external programmer, but it does have a native bootloader. It would be really cool if you could use the ROM bootloader to upload code. So we kind of sent TAC and we're like, hey, you're good at this. Go fix this up. So TAC added TinyUSB support. So we fund TinyUSB support and TAC to do this kind of development. So now it has USB device, not host. This person asking for host. It doesn't have host, but it does have device. And added support for this particular variant, the C6, the G6, which has slightly different linker script than the others. And then also, and now OpenPR is to add upload via the WCH ISP tool. So you don't need this external script. So the only thing is we don't have auto reset working. So you have to like manually reset it to get into bootloader mode, but like that's really easy compared to like having external debugger. So this is just an example of the native USB serial. So it's actually printing out like the analog 0 voltage, so I can kind of like mess with my finger and you can see it twiddles. I also have, see a couple other examples. I think onboard NeoPixel. So I wanted to test NeoPixel. And this is how normally NeoPixel works because we have NeoPixel library support, but we haven't actually added that yet. So instead, what we're doing, hold on, go to the board support package and I have I think it's just NeoPixel. Yeah. So I actually wrote some bitbang code to just like set the pin high and low and just add a lot of knobs. But it's a 144 megahertz processor, so you can do that, and it's like kind of okay with it. And then let me just enter bootloader mode. And then I'll try uploading it. We'll see if the NeoPixel slide up. So the only downside right now is, oh, I forgot. The TinyUSB support is like massive. It's like 30, well, it's not 30K, but it's like 20K. And then you need like 8K just to kind of get going. And we haven't yet mapped the external like non-zero weight flash into the linker. So it doesn't, yeah, it doesn't know that you can, sorry, everything's fine. It doesn't know that you can use that extra 200K. And so once we do that, it'll be fine. But for now, do I have to reset this? Oh wait, B6 is SCL. Hold on, let me get this wired up so we can demo it. I forgot. So the pin, also the pin names, I haven't updated them for the ground, and then I think this is SCL. Yeah. Okay. So if you go to the overhead again, whoops. So you've got your standard NeoPixel glowing demo. Yeah, I checked on the scope. It's close enough to the NeoPixel and pinout. So I had to turn off USB to do this because you can't have like just the TinyUSB just basically fills up the zero weight flash. So we'll add support for that external flash. But basically I went through like this weekend and I tested I2C and SPI. Hardware UART, analog inputs, this bootloading, NeoPixel, all works. And so the hardware's ready to send out. So I booked those PCBs. It's still like very like not for beginners, but it's really hard to say no to a 40-cent chip with like basically at mega 328 plus, or like, maybe even a lightweight Cortex M0 style capability in flash and RAM and processor speed. It does have some peripherals, and like I said, it can do USB native. It has analog inputs. You can bitbang it fairly fast. It's just a matter of whether folks want to add support for like I2S and tidy up the Arduino core support, because there's still a bunch of stuff missing. I don't know whether like the analog, PWM output works, for example. That's the WCH 32V203. We might make a Feather with there's a larger chip that has like 20K of RAM. That might be good for a Feather because it's also like 40 cents, but has, or like maybe 60 cents. But it has a lot more RAM. So, definitely you can do a little bit more complicated stuff. I wouldn't say it's quite good enough for MicroPython or CircuitPython. These are still, very low RAM, but for very low cost USB devices, I think, could be interesting. It's like, I was thinking of that, the Hackaday like business card competition. It's like, oh, this would be, a good chip to use. Okay, so that's that. So the next thing I did is work on the Feather ESP32-C6. Just have this over here. So I have a little demo right now where it's connecting to the internet every 30 seconds and then sending data to Adafruit IO. And going into deep sleep, as you see the NeoPixel, it's like connecting, green means data sent, and then it goes into deep sleep. I was using this as a way to test the low power deep sleep capabilities. So if you go to the computer, everything is okay. So this is when it wakes up. So you can see it wakes up and it draws like, 600 milliamps and does Wi-Fi connecting, Wi-Fi scanning, sending data to Adafruit IO. This is actually, it's gotten like all the sensor data ready. It sent it, and then it goes into a light sleep mode. Actually, hold on. This new interface is a little bit wonky. Okay. It goes into it goes straight into a deep sleep mode. So after it's sent, it takes, a couple seconds for it to do the Wi-Fi connection because it's starting from deep sleep. So there's like no cache data, but then once it's connected, once it's disconnected and it stays like 95% of the time in deep sleep mode, the current draw is pretty good. It's 20 microamps. So that makes sense because I'm using the RT9080, which is kind of my favorite low cost. Actually, I'll just go here. So RT, oops. I'm trying to remember what the quiescent, it's like 10 microamperes or something. It's very low quiescent, much lower than the AP2112. So when I'm doing these deep sleep, well, it says 2 microamperes. But there's also like a pull up here and there. So, oh, sorry, there's 2 of them because I have one for the external I2C and one for the internal. So it's like, you know, whatever, 5 microamps on the regulators. And, you know, I think like, yeah, 15 microamperes for the chip itself. I do turn off like the NeoPixel, although I don't turn off the Max 17048, the battery monitor, because it has to stay, as long as the battery's connected, the battery monitor should be on because it should be doing like continuous measurements. So it can like, you know, synchronize with the power draw. So 20 microamps is pretty good. I mean, I think that's, you know, that's for like a Feather board. Like I didn't used to care about deep sleep, but a lot of people were like, oh, I want low power modes. And so now I actually put a little bit of effort into, because like I'm from like the days where it's like, you just plug into 9-volt power. Why, who cares? It's kicked to the wall. Now, and a lot of people want to do battery powered stuff. Okay, so how's our time going?
12 minutes.
Okay. So I'm doing that and I measure, you know, I think I showed last week was doing various tests with all the peripherals and the Feather output. And then I did, you know, I'll show the silk screen really fast. I tried to do like kind of a nice-ish silk screen. Thanks to Penguin, it's not too hard. So this is Rev B. I also swapped, you know, on this version I have a BME 280, but honestly, not a lot of people need pressure sensing. Most people are pretty happy with just temperature and humidity, even if it's a little less expensive and less precise. So I changed it out to an HT20. So yeah, got some nice silk screen. It comes out. I mean, let's turn off the vias. Yeah, some pretty silk screen. One thing is because the pins, there's not a lot of I/O available on the C6, especially the mini module. So first off, there's 2 pins that are shared. I'll show you on the back, but then the pins don't quite match up with like my standard Feather I/O numbering, like D5, D6, D9, D10. So I label these I/O 6, 5, 6, 7, 8, and then 0, 12, and 15, because like there's no I/O 13 available, for example. And then on the bottom silk. Also, another thing I'm trying to do, add charger disable, like a little jumper that you can cut. So some folks, if they want to run off of AA batteries, you just cut this and then the charger doesn't charge the battery anymore. So you can use alkalines or nickel metal hydrides. And then there's 2 pins that are shared, A3 and IO5, and A2 and IO6 are the same. I picked these pins because you can still use this with the RGB matrix feather wing. So it's like all of our feather wings will work because we don't usually use the analog pins, but the RGB matrix feather wing is the only one that does. Okay, so that's that. So let's go to the great search and then I'll just show off my next design.
Where in the world is that part I need? The great search with Digi-Key.
The Great Search brought to you by Digi-Key and Adafruit. Thanks, Digi-Key. Every single week, Ladyada, user power of engineering, help you. Yes, you find things on Digi-Key.com. What are you searching for this week?
Okay, so this week I've been working on the C6 Feather. So maybe go to the overhead. I'll show it real fast and I'll talk about the new design. So this is the C6 Feather. It has this really adorable, I think we covered this on the Great Search and INMPI. The C6 has Wi-Fi, Bluetooth, like Wi-Fi 6, Bluetooth 5, and Zigbee 802.15.4, which means it's really great for home automation, sensor networks, because it's got like pretty much every network except cellular built in. And it's very low cost. It's very affordable. It's kind of like an upgrade to the C3. I kind of like the C3, but it had very few pins. This one has a little bit more GPIO available. It doesn't have native USB that can do like mass storage, but it does have USB that can do serial. So it has a built-in serial port and built-in bootloader, which is like still better than the ESP32 or 8266, where you needed a separate chip to do the USB serial conversion. So this board's pretty straightforward. You know, got stem QT and battery and the button and reset, NeoPixel, and then this module and a lot of GPIO. But as I was doing this and I was sort of starting to chat with some of our devs about, hey, let's let's start adding CircuitPython support and let's build some demos with this. One of the things that's interesting about this is it can act as a bridge between Wi-Fi and Bluetooth and Zigbee, or Wi-Fi and Zigbee, or you to use USB and what, it's like it's kind of a nice, like, oh, because it can do four protocols. You can move between the two. And also I think this, because it could read sensor data and then send it over Thread or Matter, or Wi-Fi or Bluetooth, it would make for a great like sensor node. Something that's low cost. You can put it in multiple rooms. It would sense data and then send it via your favorite protocol. Wi-Fi if you're cool with using an online service. Zigbee if you're doing like in-home automation, or Bluetooth if you're sending it to your tablet or your phone, or you're making like a network, a mesh network. So what I wanted to design, if you go to the computer, is what I call like a Trinkey. And in the shop, maybe I'll show it off. We have like this TRS Trinkey. It has USB, and then like they're meant to be very small. They're like USB keys, but they're like, instead of storing your files that you are sneaker couriering over to your friend in the other computer lab, they have some sort of input or output. So we've got like this TRS Trinkey, and we made an enclosure for it as well. And then there's like the Pixel Trinkey. Again, simple, plug into USB. It has NeoPixel control out. Very, very simple. But I wanted to make one that, instead of using the SAMD21, use the ESP32-C6. Two copies of this available. So let's do the basic top. So this is a very simple prototype because I'm just getting started with this design. This is the USB connection, 2 buttons, regulator, JST 4-pin for I2C, 3-pin for power, ground, and I/O. So you can connect like NeoPixels or a button or a servo, potentiometer, relay. You can kind of connect generic stuff to it. And then over here, the module. So this prototype, this is just to kind of get the idea, does this even work? But what I really wanted was to have like an adorable enclosure for it, because if you're going to have it in your house, it'd be nice if it was like nicely protected and it didn't like look like electronics just kind of plugged into your USB outlets. And like I said, we have this TRS Trinkey enclosure, and that's great and everything, but I wanted something clear, and it's a lot tougher to do 3D print in clear. You can, but it gets much more expensive. So when I remembered that over at Digi-Key, you can actually get USB key enclosures, a couple different sizes, in clear or translucent, and at a really good price, about the same price what you would pay for injection molding. And so if you can use these cases, as long as you don't need like 100,000, at which point you might want to go to injection molding. If you're only using a couple thousand, they can be a really elegant way to enclose your design. So let's go to Digi-Key and let's search for, first off, we're just going to look for enclosure. Because I'll actually tell you the truth, there's no category called USB enclosure. Instead, I went to enclosure, and then I was like, well, let's just at least just get rid of like the inactive items. So it's whatever, get rid of some things. And then I was like, okay, well, like the first one actually turned out to be like a USB enclosure, which is kind of funny. Sorry, the second one. But I noticed that like I was like, okay, once I find something I like, I'm like, well, what did I have to select to get there? So the thing is that the color is clear, which is good. That's definitely what I want, but there's no feature that says USB. However, it does say split sides. So that's kind of like what I ended up. And then there's like a couple others that are sort of small. I think I found, here's another one that's USB, and like that one, it's translucent clear, handheld, split side. So Handheld is kind of, I mean, these are much more complicated because these are very like specialized, and some of these are just like boxes for holding things. But since we don't have like USB, let's first look for clear. So at least we'll just get the, you know, we won't get anything that isn't translucent. So at least that gets us from like 20,000 down to like under 2,000. Better than nothing. So that's the color. Next, for the material, we don't want metal because we want it to be translucent. You know, I think I want clear. So I'm going to deselect all the metal to have only the clear ones. And I could try filtering by size, but honestly, I think it's going to drive me a little bonkers. I think what I'm just going to do is look for split sides because there's this USB connector. You can see the little slot for the USB type A. It's always going to have like split sides. So let's look for handheld split sides. Maybe handheld cover included. Split sides with cap. Definitely not open ends, not drawers, and not hinged. And not covered because this is not like a hinged thing. That's going to be something that snaps closed. Okay, so at least it gets us to 200 or so. So let's see what we got. So actually what happened is that this actually got us pretty close. So we got a couple different cases. This is like a 2.5 by 1 inch. This is 2 by 1 inch. There's still some of these enclosures that are like they're 2-piece and they have a translucent thing. But it does do a good job of getting us the core of the USB cases, and then we can just ignore these bigger things. One thing we could do is we could sort by size, but I was actually fairly satisfied with these ones over here, and I ordered a few. So maybe let's go to the overhead real fast, and I'll show off what I got. So this is the Hammond. Hold on, so it's 155 USB 2. This is kind of the medium size. This is the Bud Industries USB 7201. So what I kind of liked about this one is it's very clear because it's not, this is like ABS maybe, and this is like polycarbonate. So it's not machinable, but it has a nice cap as well. I got 2 of those. This is the USB 2. I got 2 of those one. And then I also got this one. This is the Bud USB 7202, which is like totally adorable and very small. This might actually be a little bit too small because it looks like I have to have it fit within, you know, like 0.6 and 1.3 inches, which is tiny. I mean, if you have like no other accessories, if you want something but if you want something extremely adorable, this is a great little case. I already snapped it together. The only thing is, you know, once you snap these together, they don't come apart very carefully. Okay, so 2 pieces and a cap. So it's the 7202. And then I also got, just for fun, I got smoke. It's the USB 2, but in translucent gray. Because I was like, well, maybe I don't need to. I want the LED to shine through, but I don't need it to be like fully clear. So for machinability, the Hammond 1551 USB 2, this is definitely going to be the winner. Because first off, you can easily remove it. You have 2 screws on the end here. But it's definitely got a lot of room in it. It's kind of got this split, you know, connection, so you can have components on both sides. Nice and chunky. And then, you know, within some reason, check the data sheet, but it's about like 1.8 by 0.75, you know, ish. Like I said, this one PCB has to be, you know, 0.6 by 1.3. And then this one, the PCB has to be 0.75 by about 1.9. Looks like maybe, you know, if it's, yeah, like 2 or 1.9, depending on, you know, how you handle the notch. So for machinability, the Hammond, but the one I actually like the most is this Bud one. This is the 72. Oh man, now I forgot which one is which. Hold on. This is the, yeah, sorry, 7201. Confuse me. So this one, because I like that it came with a cap. It's got 2 pieces, but there's a little bit of clearance. It's just kind of the more elegant one. And one thing I liked about this is that it has like a truly clear display. So if you wanted to put an OLED in here, like this one, you know, you could see kind of sort of through it. But with this, you know, LEDs or OLEDs or TFTs, like if you had, it's not that much bigger than a Feather if you wanted to use one of these 1.14, like 1-inch diagonal color displays, I think it could make for a very cute little kit. And then of course, I love that it has like the cap. It comes with a cap for keeping it nice and safe. So let's go back to the computer. So this is it. USB 7212. Price is about $1.50 in quantity. Again, if you're making less than a couple thousand, this is going to be cheaper than injection molding, and it looks beautiful. So this is my pick for the Great Search.
Where in the world is that part I need? The Great Search with Digi-Key.
Alrighty, we'll be seeing y'all during the week. We're going to have some changes in schedules for the summer months as Adafruit grows and we take on some new factory
adventure.
space. So we'll be announcing that soon.
Yep.
And see you online throughout the week. Bye, everybody.
Thanks, everybody.